Hello and welcome to Unity Insights. Today I come here with another useful video about Unity learning. Those who don't know me, myself Somnath Chaudhary and I am a professional Unity developer. In today's session, we will explore Unity's camera component. If you're still struggling to understand the icons above game and scene window, then I have made a complete video on it and explained each of them with example. Do check it out if you are interested. Camera is a very important component. Whether you are planning to develop a PS, which is first person shooter, TPS, which is third person shooter, 2D, or any type of game or interactive application, you definitely need one or more cameras. Camera is basically the device which captures and displays the world to the player. Let's try to understand the camera properties in Unity Editor. Here I have added few default shapes. You can see it here. This is the hierarchy I have maintained. Okay. Now, whenever you create a project with 3D template, by default you will see these two game objects are there. One main camera and one directional lines. So if you want, you can delete the camera. So whenever you are deleting, so your game view, you can see display one no camera rendering. Means there is no camera to render anything. To add a new camera, what you can do, right click in the hierarchy and click on camera. Okay, and then you can give it a position wherever you want, the reset, and put it -10. So that is was the main camera's position. Another way to create camera, you can disable it and create a empty game object. Okay, reset the position, put it -10, and add a component called camera. So now you can see there is a camera. So you can have n number of cameras in your project. So probably one camera would be rendering only the UI elements, one camera for minimap, one camera for gameplay, and so on. Now to rename these game objects with the cameras, you can give it any name, probably bottom camera, like this. So I've added this camera for my reference so that I'll know this is a camera component. It's attached to this game object. Here already camera is written. So I can give it a name as a top camera, something. So this is how you can rename the cameras. Let's try to understand the properties of camera. So first property of camera is clear flag. If you hover on it, you will get a small description about it. What clear flag does, it says like whatever its empty area. So you can see four shapes are there. Behind four shapes, what we should render. So as of now, we have mentioned render a skybox. So that's why you can see a skybox is rendered. If you don't want skybox, there are few other options are also there, like solid color. If you want to choose solid color, then under this background, you can select whichever color you want. So based on your chosen color, it would be displayed. Next option comes depth only, which means in that empty area, don't render anything. Just keep it as black. So you can select as a depth only to don't render anything else in that empty area. And the last option is don't clear, which says like whenever your object is moving, don't clear the last frame. So if you go in play mode and then if you move the cylinders, for example, now you can see it's not clearing the last frame. It is frame by frame, it's saving. So that's how it works. Our next parameter is culling mask, which says which layer it should render our camera. So for example, let's take the 3D object. Here you can see it's a default layer. Even my cylinder is also in default layer. Okay. If I in cylinder, if I put a new layer, so for that I'll click on add layer and add a new layer called something new or whatever name you want, you can keep it. And now this cylinder, put it under new. So now this is the new. Now I'm telling my camera, do, I mean, don't render anything except new. So now you can see only this object will be rendered by this camera. Now let's enable the top camera. Okay. So top camera will render this three. Now if I disable this camera, okay, let's change the top camera, and here under this culling mask, put disable the new. Okay, so top camera will render everything except new, and the bottom camera will render only new. So now you can see there's a four objects can be seen. Our next property is projection. Under projection, you will get two options, either perspective or orthographic. Perspective, it shows like 3D camera, and if you change it to orthographic, now you can see it's a rectangle box type. Okay, so where you have the near and the far area. This orthographic mostly we use during our 2D games or 2D applications. So orthographic will render objects uniformly. Let's see one example. So let's disable this one, and the top camera is perspective. Okay, so now if you go back, now you can see the objects are going far and near, something like this. All right, let's revert it to 10, and now see how this orthographic camera is behaving. So through this orthographic camera, we are seeing the cylinder. Okay, if you disable it, you can see it's only rendering the cylinder. Now if you move front and back, see nothing happens to the cylinder in the game view because it's uniformly it's rendering. So that's the difference between perspective and orthographic. Orthographic camera has a size. So if you change the size, if you increase it, the object goes far, and if you decrease it, the object goes near. So now you can see this white rectangle how it's changing based on the size. Okay, so this is for orthographic, it is the size, and if you change it to perspective, then you will see different options. In perspective, you get these three options. Okay, so FOV axis, FOV stands for field of view axis. So where you get two options, horizontal and vertical. So based on your game's orientation, you can choose whichever axis you want. The next one is field of view. So now if you change it, the field of view, now you can see in the editor how this angle is changing, right? So the less means it's more zooming into the object, and the more means it's going far away. Okay, and the default value is 60 here. Our next property is physical camera. Whenever you need a physical camera, like real world camera, to render, you can enable this and you can manipulate the values. Whenever you enable this, you get like different options where you have a focal length, which is like the distance between the sensor and the lens in millimeters, right? And you get a different sensor type. So there are a list of sensor types. You can choose whichever sensor type you want based on your requirement. Next, sensor size, which says like different size of sensor. Whenever you're changing, you can notice here how the sensor size is changing, right? So similarly, you can change to Y size as well, right? Lens shift. What happens if you if you want to change your lens, shift your lens, you can use this. Now you can see my camera is here, but my lens X value is shifting toward the right or the left, however you want. Similarly, you can do for Y as well. Right? Let me reset it. Next is gate fit. You get a different options for this gate fit. So based on requirement, you can choose either vertical, horizontal, fill, overscan, and none. So all these options you are getting. So whenever you need a physical camera, then only you can enable this one, or else let it be disabled. Our next property is clipping planes. So here you get a two plane, near plane and a far plane. So for this example, for bottom camera, let's focus on it and go near to it. Now you can see there is a near plane, okay, where you can see the rectangle is starting. Okay, that is the near plane. The value is 0.03 and the far plane is 1000. So if I change it to somewhere 0, now you can see here immediately that changed to origin position, means 0 0 it's starting. Okay, so let it be at 0 value, and the far plane is 1000 is too far for us. Just change it to 100. Let's see if it is, or maybe 10. Okay, now you can see how it's changing the far plane. This is the far area, the big rectangle. So if I change it even less, now slowly once it is like below that, you can see the cylinder is not visible now because it is out of the camera boundary. Our next property is viewportrect, where the value stays between 0 and 1. So let's try changing the value. Let's say 0.3 and y also 0.3. You can see here. Okay, let me try changing some other camera so that you can understand it better. Let me revert it to 0 0, and on top camera we'll try that. Let's do it 0.3 again. Now you can see how it's changing. 0.3. So this is how you can set the viewport size, right? So width, if I mention 0.2 and height also 0.2, now you can see it's 0. 0 means left, and again 0 means bottom left. If I change it to 1, sorry, 0.2 minus, so it should be 0.8, right? You can see here 0.2 and then 0.8, so totally it becomes 1, right? So it would be top left. Again here if I put 0.8, then it goes top right. So this is how you can set your viewport size and position. Our next property is depth. So as of now you can see both the camera has depth 0. Right? Now if I, for bottom camera, if I change it to, for example, skybox or solid color, something different, I can see you cannot see the other objects. Although both the cameras are active and both the cameras are almost in the same position. Now here depth plays a major role. So if you have a camera, okay, in the top camera, if I change it to 1, now you can see the top camera is rendering along with skybox and the objects. Now bottom camera, we cannot see the cylinder from bottom camera point of view. What we can do here, not only depth, you need to change the depth only also, so that except the object, nothing else will be rendered. Now you can see all four objects from both the cameras. That means the higher value of depth will be rendered on top of lower value of depth. So if your higher value of depth has skybox, so behind any other camera if you keep, nothing will be rendered. So make sure whichever is your higher value camera or highest value camera, make them under depth only so that you can see the other environment as well. Our next property is rendering path. Here it defines like which rendering method will be used by the camera. So for different camera you can have different rendering method. Okay. Under rendering method, sorry, rendering path, you get this many options. So these options you can select. So for example, if I select vertex click, it would be little different. So if you hover on it, then you will get a small description about rendering path, right? You can see it here. So this would be even more useful whenever you use URP or HDRP pipeline. So wherever you can see this graphics, use graphics setting. So those are mostly used whenever you using URP or HDRP pipeline. Target texture, it captures the camera view into a render texture. Here you can see there is a property called render texture it's showing. What you can do, under your asset, you can right click, create, and click on render texture. Okay. Let it be whatever name you want, you can change it and set the resolution whatever you want. Right. So I'm putting here 1920 by 1080, which is full HD. Now what I can do, and in the top camera, I can just drag and drop. So whenever your target texture is assigned, that means on your screen, the object will not be seen. Right? How we can see the objects now? Here you can create under UI, create a raw image, and this raw image you can see here. And now under this texture, drag and drop this texture. You can see it here. Let me make it even big, 500 by 500 or something like that. So now you can see it is rendering on raw image. So whatever camera output is there, that we are rendering into a raw image. This would be useful whenever you have a big world environment and if you want to create a minimap out of it. So place a camera at the top so that it will capture the whole environment and then draw it in your raw image. Occlusion culling disables the object which are not rendered by camera. So if my camera is uh, moving or seeing somewhere else, so the objects whichever outside of camera first term should not be drawn. As of now, you can still see the box and the capsule is still drawn. Okay, if my camera is not seeing, even though it's drawn, what we can do, click on this 3D object. Okay, so whichever object you have, make them static. I already made them, so first disabled. So click on the static button and click on just change children. Means this all objects are static now. Next, what we'll do, click on this window, rendering and occlusion culling, right? And click on bake. Once you click on bake, now you can see so many rectangles came. Now click on the top camera and try to rotate. Slowly you will see whichever object is outside my camera frustum. Here in scene view, you can see it is getting disabled. Right? It is not rendering. So this is useful whenever you are trying to optimize your game or application. This would be useful. HDR gives you a wide range of light intensity. HDR stands for high dynamic range. So whenever you're using URP or HDRP, you might be playing with those lighting effect or anything. So for that, HDR would be useful that time. MSAA, which is multi-sample anti-aliasing, this is to reduce the zagged line. So for example, let me try make it dark so that we can see kind of zagged lines. Right? And in my cube, let me try rotating a bit. Right? If you zoom in, now you can see so many zagged lines are there. Okay. So whenever in this case, what we can do, go to edit, project setting, under quality, here we have anti-aliasing. The default value is 2x. If you change it to 8x or something, now you can see the jack line reduced. Okay. So MSA is useful to reduce these lines. Allow dynamic resolution. This setting will allow you to individually scale up the rendered targets so that your GPU will have less workload. Okay. Next is target display. As of now, we have one display where all the objects are drawn. But if you want, we can have one more display. So let's click on triple dot, click on add, and then click on game. So this object will put it as 2. And one of our camera, so for example this top camera, will make it as target display 2. So now you can see our bottom camera is target display 1 and the top camera is target display 2. So here you can set the target display. This will be useful whenever you have multiple screens. Okay, you have external monitor or something. So for that case, this would be useful. You can have up to 8 target displays. To know more about the camera, you can visit Unity's documentation. So you can visit this URL, and here from this drop down you can select whichever editor you are using for your project. So based on that you will be able to see the camera properties details. That's it for today's video. Thank you for staying with me until the end of this video. I hope you got some insight about Unity's camera component and I'm able to explain the properties of it. Do comment down below or send your query via email. Until next time, keep learning.